Good day everyone! Welcome back to my online math class. I am Teacher Ray, your teacher for today. Today I am going to discuss Lesson 7.2, Understand Theoretical Probability. This is in your textbook pages 361 to 366. Last week we learned about Lesson 7.1 and it was all about understand likelihood and probability. So what do you remember about this lesson? What does probability mean? You got it right. Probability tells us about things that only sometimes happen. It might be likely or it might be unlikely. Just like in math, we do things that always happen in the same way, and they are completely certain. Just like if you add 1 and 1, you're always gonna get 2. If you multiply 2 and 3, you're always gonna get 6. There is no one uncertainty at all. But in the real world, things are so unpredictable. Take a coin toss for example. We can predict whether it will be head or tail. It is so unpredictable or random. That's why some people will flip the coin to decide which of two things to do. Now, let's have your answer for practice in problem solving last week.
Number 9. Marcus is rolling a number of cube with size labeled 1 to 6. Part A. The probability that a number cube will show 10 is 0. Part B. It is impossible that a number cube will show 10. Number 10. Of the marbles in the bag, 3 are yellow, 2 are red, and 2 are blue. Sandra will randomly choose one marble from the bag. A. The probability that Sandra will choose a blue marble from the bag is 2 out of 7 or 2 over 7. B. It is unlikely that Sandra will choose a blue marble from the bag. (13) Suppose Nigel has a bag of colored wristbands and he chooses one without looking. The bag contains a total of 25 wristbands and 6 of the wristbands are blue. A. What is the probability that Nigel will choose a blue wristband? It's 6 over 25. Letter B. It is likely, unlikely, or neither likely nor unlikely that Nigel will choose a blue wristband. It is unlikely. Number 17. After many studies, a researcher finds that the probability that a word recognition app correctly interprets a handwritten word is 9 over 10. Which statement is true? A. It is impossible that the handwritten word will be correctly interpreted. B. It is unlikely that the handwritten word will be correctly interpreted. C. It is likely that the handwritten word will be correctly interpreted. And D. It is certain that the handwritten word will be correctly interpreted. Here are the objectives of the lesson. You will be able to understand theoretical probability and how it can be used. Use theoretical probability to predict an outcome.
Oops! Don't forget, you must have your textbook, copybook, and pen. Have you ever heard someone ask what are the odds? Usually, what it is meant is how likely is it that an event will happen? Today's lessons explores finding the likelihood or theoretical probability that an event will occur. It is calculated by dividing the number of favorable outcomes by the total number of possible outcomes. Try to look at this example.
A letter is selected at random from the word watching. A. State the number of possible outcomes. There are 8 letters in the word watching, so the number of possible outcomes is 8. B. What is the probability of selecting a vowel? The probability of selecting a vowel is equal to the number of favorable outcomes divided by the total number of possible outcomes. In the word watching, there are 2 vowels, A and I. The favorable number of outcomes is 2, divided by the total number of possible outcomes is 8. And this is equal to 1/4.
How can you use the probability of an event to make a prediction? Think about this question during the lesson. Talia and Yoshi design a game for the school fair. Contestants spin the pointer and win a prize if it lands on either of the 2 red sections. How can Talia and Yoshi determine how many people are likely to be winners if 500 people play their game? They can determine the number of people using probability. How can you use probability to predict the number of winners? The first step is to determine the total number of possible outcomes from one spin of the pointer. There are 16 sections that are all the same size. There are 2 sections of each color. The pointer could land on any of the 16 sections, so there are 16 possible outcomes. Which outcome is most likely?
Select your answer.
Each section is the same size, so the 16 possible outcomes are equally likely. Because you know all the possible outcomes, you can find the theoretical probability of an event, such as the pointer landing on red. The letter P represents theoretical probability. An event is a single outcome or group of outcomes. The probability of an event is the number of favorable or desired outcomes divided by the total number of possible outcomes. In this situation, the event is the spinner landing on red. The probability of landing on red is equal to the number of red sections on the spinner divided by the total number of sections. There are 2 red sections and 16 total sections, so the probability is 2/16, or 1/8. The theoretical probability that a contestant will win this game is 1/8, or 12.5%.
Drag tiles to match each probability to its event.
There are 2 yellow sections in a spinner, so we would choose 2/16 or 12.5%. Since there is no black in the sections of the spinner, so the probability is 0/16 or 0%. How about the probability of the spinner landing on red or yellow? Since there are 2 reds and 2 yellows, so the probability is 4/16 or 25%. How about the probability of the spinner landing on red, yellow, or green? So there are 2 reds and 2 yellow and 2 green. Therefore, the probability is 6 out of 16 or 37.5%. How about the probability of a spinner landing on a color that is not red? There are 14 sections that are not red, so the probability is 14 out of 16 or 87.5%.
Our last step is to use proportional reasoning to predict the number of likely winners, which we'll represent with the variable W. The probability of choosing red, or 1/8, is equal to the ratio of W to the total number of contestants, which is 500. Multiply both sides of the equation by 500 and simplify. So W equals 62 and 5/10. Of the 500 contestants, about 62 are likely to be winners.
Let's do try it. If Talia and Yoshi redesigned their spinner to have 14 sections instead of 16 sections, would they likely have more or fewer winners? Explain why. It would be more. The theoretical probability of the pointer landing on red is 2 out of 14 or 1 over 7. And 1 over 7 is greater than 1/8.
Archie plays a word board game. He places 98 lettered tiles and 2 blank tiles in a bag. Players will draw tiles from the bag one at a time without looking. What is the probability that the first tile drawn will be a blank tile, labeled with a letter, a vowel, a consonant?
Fiona plays a word board game. She places 98 lettered tiles and 2 blank tiles in a bag. Players will draw tiles from the bag one at a time without looking. What is the probability that the first tile drawn will be either J, K, or L?
The probability that the first tile drawn will be either J, K, or L is 6 over 100 or 3 over 50. The probability she draws either J, K, or L for the first tile is 3 over 50.
Joaquin designs a game for the school fair. Contestants roll 2 number cubes at the same time. If the sum of the numbers on the 2 cubes is 7, the player wins. About how many winners should Joaquin expect if 500 contestants play his game? The first step is to find all possible outcomes and all winning outcomes. One way to find the possible outcomes is to roll the dice over and over again and record every outcome. However, this method would take a long time, and repeated outcomes might occur before new outcomes. Instead, make a table to show all the possible outcomes. List the possible outcomes of the blue number cube to label each row, and the possible outcomes of the red number cube to label each column. Then fill in the table. For example, if the blue number cube shows 6, then the possible sums of the two cubes are 7, 8, 9, 10, 11, and 12. Complete the other rows in the same way. The table shows that there are 6 outcomes that have a sum of 7, which means there are 6 ways to win out of a total of 6 times 6, or 36 possible combinations of rolls. Now we're ready to find the theoretical probability of rolling a sum of 7. The probability is equal to the number of outcomes that have a sum equal to 7, divided by the total number of possible outcomes. There are 6 outcomes with the winning sum of 7, and 36 possible outcomes. So the probability is 6 divided by 36, or 1/6. Now we're ready to use proportional reasoning to predict the number of winners, which we'll represent with variable W. The probability of 1/6. The number divide the total test, which is 500. Apply both sides of the equation by 500 to find that W is equal to 83.3 repeating. Of 500 contestants, Joaquin should expect about 83 winners.
Joaquin wants to reduce the number of winners so he does not have to prepare as many prizes. Choose another sum he could use as the winning sum and predict the number of winners if 500 people play his game. Joaquin could choose a sum of 12 as the winning sum. The probability of a sum of 12 is determined by dividing the favorable outcomes by the total number of possible outcomes. The favorable outcome is 1, and the total number of possible outcomes is 36. By using proportional reasoning, 1/36 is equal to the ratio of the number of winners and the number of people who will play the game. Multiply each side by 500. And W is equal to 13.8. So he should expect about 14 winners.
And now we're done with the first part of our lesson. Hope you understood the lesson very well. See you in the second part.